zero sequence network for a load. Zero sequence network is a very important the diagram you have to draw with the utmost care, because the zero sequence currents are same in the magnitude and they are all in phase at any point in all the phases of the system. Therefore, the zero sequence current will flow only if a return path exists through which a completed circuit is provided. That is, the zero sequence the network you have to draw in a such a way that when there is a return path for the zero sequence network is there, then only there is a existence of zero sequence current. If it is not grounded, then there is no existence of zero sequence current. The same thing is written here, that is, the zero sequence network currents will flow only if a return path is existing. Only zero current will flow only if a return path exists, then only there is a flow of the zero sequence current. Therefore, the reference bus of the zero sequence network is grounded. Then the reference is grounded with that network. For example, if you are taking a star connected load here, here it is not grounded. It is not grounded here. Therefore, there is no existence of zero sequence current here. You are not any marked here zero sequence current. Therefore, there is no path for the current to flow to the ground here. Therefore, then how we are representing this network? This network is represented with simply, that is, the current. Suppose you are assuming that the current is entering here. Here afterward there is no path, means there is no flow to the ground here. Therefore, there is a break in between. Therefore, the same representation per phase basis for ungrounded the network is represented by its zero sequence impedance Z0 with open between the neutral and the ground. Here, if we are calling this as a neutral, from here neutral to ground it is open, because further there is no flow of the current path, therefore it is shown as the open here. In contrast to this, suppose the system is grounded here, what I have shown here. Then if you are assuming the current which are entering here, that is, you can call it is IA naught, then it is called as IC naught and IB naught here. In that case, the current which are entering here, all the currents they are entering here, then they are flowing here, then they are passing to the ground. Therefore, on the basis of a single phase basis, if you are drawing this network, then if you are trace the current direction here, the current which is per phase basis, it is flowing here, then it is passing here, and it is flowing to the ground. Therefore, a network can be completed to the ground through this wire, that is grounded wire. Therefore, return path is there. Therefore, you can draw here, that is, from this you can call this is A. From this point A, the current which is flowing here, and it is a Z0 here, this is Z0 here, this is a neutral here. From neutral to it is ground, therefore it is neutral to ground, it is shorted. Means there is a existence of a return path, therefore the circuit is completed in this particular the manner. This is how we have to draw the line. Now, the third case we are considering here, it is a return path with the impedance. You can see here, zero sequence current with the grounded with Zn. Once again, you can see here the currents which are entering here are, you can see here IA naught, because all zero sequence current having the same magnitude. Therefore, I am representing here IA naught, and all these three currents, they are entering into this particular node, and it will come out from this as a 3 times IA naught. The total current which is 3 times IA naught, and they are flowing towards the ground. There is a return path for this particular the network here. Therefore, per phase basis, if you are drawing here, then what you have to take? You have to take this path. this path you have to take to the ground. That per phase basis you have to draw. But while drawing once again the per phase basis, the current which is here is Ia naught, whereas the current here it is 3 times Ia naught. And you should not draw the series circuit with Zn with 3 times Ia naught and Ia naught. Therefore, once again I am making a adjustment here that this 3 can be added to this Zn. Therefore, if it is become 3 times Zn and the current is reducing to Ia naught. That is for representation purpose I am telling. That is, here also current is Ia naught. Here is also current Ia naught. However, impedance you are taking as 3 times Zn. That can be written in the equivalent circuit diagram here. That is, it is written here. That is, you can see here, it is Ia naught, it is a Z naught, Ia naught, Z naught, and here the current is 3 times Ia naught. That is readjust by making it is 3 times Zn and remaining only Ia naught. Therefore, what I am writing here is 3 times Zn and the current is also once again here also Ia naught. This how you have to draw the zero sequence network for the grounded system through an Zn impedance, external impedance. Then if the system is the delta connected, if the system is the delta connected, that is the case, and if you are looking into here, the current which are entering into the system is Ia naught, Ia naught, Ia naught you can call, because once again the currents are equal. But here in the delta connection, as such there is no return path. As such there is no return path. It is offering very infinite impedance. Therefore, it is shown as for zero sequence current, it is shown as the open circuit. That is shown as open circuit. However, the zero sequence current, they are circulating inside the delta, that is represented as Z naught with the reference bus. With the reference bus, the zero sequence current, they are circulating inside this loop. However, in the line there is no existence of zero sequence current for the delta connected load.